Hello and welcome back to another CTF walkthrough. Today we're going to be doing Thompson from TryHackMe. And this is, via the description, a boot to root machine, which was for actually a few conferences a while back. So this is an older machine and it's not going to be as complex as some of the other ones I've gone over. But I did this machine earlier today and I thought it was simple enough where it is super beginner friendly, but also complex enough where there's a few tips and tricks that I'd like to share with you all. So this machine was a nice balance between simple and complex that I'd like to go over. And it's not going to be a long video, but it's going to be pretty in depth. So without further ado, let's jump into it. And I've started the machine. I'll grab my IP, head over to Kali Linux and start my Nmap scan. But first I actually need to make a directory called Thompson, feed into that, and then run my Nmap scan. So -T4 is going to be a timing thing. We're going to run the scan a little bit more aggressively in order for the scan to finish quicker. -A is going to encompass all flags, so that includes -SC, -SV, and -O. So -SC for default scripts, -SV to enumerate versions, and -O to enumerate operating system information. And then we're going to output that into an nmap.txt file. And it comes back pretty quickly. We have SSH, we have an Apache JServe, and we have Apache Tomcat 8.5.5. So immediately, my mind jumps to Apache Tomcat 8.5.5. This seems like an older version, so there may be some vulnerabilities here, but let's jump straight into Firefox. If it loads. And we can just enumerate this web server right away. And obviously from the box you saw a little bit of stuff I've been going through already. But we'll go here and we'll go to, let's check out 8009 first, because that's not really a default port. And it looks like we aren't going to be able to navigate to it. I don't know what AJP13 is. I guess that's Apache JServe version 1.3 actually. Yep. So we aren't going to be able to connect to it traditionally as we would with an HTTP server. We can go to 8080, and here is what we expect: Apache Tomcat 8.5.5. I'm going to run an ffuf scan. You can use GoBuster for this as well. I've been starting to use ffuf a little bit more. I find that there's just a little bit more flexibility, and it's a little easier to use. I mean, they're both incredibly easy to use, but more so the flexibility side of things has been what's been drawing me more to ffuf. It's sort of a Swiss Army knife. I can use it for everything web, whereas opposed to GoBuster, I can just use it for busting directories and subdirectories, and that's kind of it. So I've been using ffuf a little more. This may be a temporary thing, who knows, but either one works, whatever your preference is. We can run big.txt and it's going to start rifling through these, and it's pretty fast, right? 900 requests per second. That's really nice. But we can start looking around here. This is the default Apache page, so I'm expecting to see default Apache results here. But we can look through, and the first thing I like to do is go to the manager app, and it's asking us to sign in. If we could cancel here, we have 401 authorized, but a really good thing, not good thing, but the really silly thing that Apache Tomcat does is it gives you the default password, right? So for example, add the manager GUI role to username Tomcat with a password of secret to the following config. So this is the default username and password that comes with this version of Tomcat. So naturally, let's see if we can exploit that. Go to manager app again, username of Tomcat, and then we'll paste our password of secret, sign in, and there we go. We are able to get into the application manager of Apache Tomcat. And immediately there's not a ton of stuff that sticks out here. Like there's no usernames, there's no passwords, there's nothing out of the ordinary. But the one thing that I did learn from this box and from a box I did a while ago is this war file. So a war file is essentially you can make it into an executable, though I don't know exactly what it is. Web application archive, and it's for Java-based web development. But yeah, this is essentially just executable code that we can run. So we can just run a reverse shell with a war file. So I'm gonna go to revshells.com. one of my favorite websites of all time, to be honest. We'll search up Java, and I don't know which one I want. I want msfvenom, and I want a war file. So maybe I'll just do it through msfvenom to start. So like, let's do msfvenom venom. The payload is going to be Java, and let's see what it has. Java. Let's do JSP reverse TCP, I think, and then we'll do our lhost is going to be RIP, so 10.6.3.169. Our L port is going to be, we can just do 4444. And then the file, or like the extension is what I think of this as, is going to be war. And then the name is going to be, let's just do shell.war. Hopefully that generates properly. Yeah, I didn't know that msfvenom could actually generate a .war file until today. So this is a new learning for me. So if I mess this up, my apologies, but it looks like it worked. So we have shell.war now, and we can browse. We can go to home, TryHackMe, Thompson, shell.war, open, and we can click deploy, and then we see it. We have a path leading to it, but we're gonna have to listen. I've been using Penelope to listen. This is a new tool for me. It's essentially just you'll see here. So I click on shell, it'll go here, and we see we get a shell. And what it does is it is very similar to any listener out there. You're going to listen on port 444 on all of these IP addresses. Then it's going to get the reverse shell. And the nice thing about Penelope is it's going to attempt to upgrade it immediately depending on what's on the system. So here it's trying to use PTY and Python 3 to upgrade the shell. Unfortunately, it cannot get the TTY, which is fine. And actually, earlier today, I did notice this when using Penelope. It's a tool I want to introduce because I think it's really cool and it works like 99% of the time. But for this particular shell, I actually can't interact with it. So I'm pressing enter, I'm typing, pressing Control-C, and nothing works. So if you're going to use Penelope, I guess don't use it for .war files or Java-based files or something. It's something weird's happening here. But I'll exit out of that, and I'll just listen the old-fashioned way. I'll do RL wrap and see I'm going to be 444. Refresh this page. We have a connection. It's not TTY, but we still have command execution as the Tomcat user. So that is the initial shell on the box. That's going to be our initial foothold. And I believe this is also where we can get the user flag. We go into home. There's a user called Jack. CD into Jack. LSLA. Let's see if we can get SSH. I guess there isn't one. I thought there would be a SSH flag or SSH file since SSH is open on the machine, but there's not. But regardless, we have read access on user.txt, so we can grab the user flag right here. I also want to look at this wget history. Okay, it's nothing crazy. I didn't really enumerate this user share as much as I should have, mostly because if you're seeing this, something should be standing out immediately. And this is the id.sh. We see the big thing here is it's owned by Jack, but we as this last triplet is other users. So anyone that's not the owner, so in this case, Jack, we have read, write, and execute access on this file. So depending on who is running this file and if it gets ran consistently, we can actually manipulate this to get further access into the machine. So if we cat id.sh, we see, okay, it's a very small script. We see it's a bash script that is running the id command and it's putting it into test.txt. And as we can see in this home file, we see that test.txt. So we can cat out test.txt. And interestingly, we see that the ID is actually root. So what does this mean? This means that some somewhere in the history of this machine, this command was ran by root, or this script, this bash script was ran by the root user, because this artifact here, test.txt, is the result of this command, id into test.txt. And I can do that too. id, I'll do test2.txt. So what does that actually do? So it creates a file. We see, I might actually have write privileges. So let's see, temp, id into test2.txt. LSLA, we see test2.txt, cat it, and we see the exact same output except for our user. So what this means is the root user ran this bash script, and the output of test.txt is that root user. So once again, the conclusion here is, I'll cd back into home jack. Can't clear the screen. I can't, that's annoying. The conclusion here is the root user is running this script. But why does that matter? Well, it matters because, as I mentioned before, we have read, write, and execute privileges, but most importantly, write privileges. So if the root user is accessing and running this script as the root user, as the highest privilege on the box, and we can manipulate this script, then we can potentially get and do something as the root user, right? Because the root user is running this file. And if we can arbitrarily write, right, as we can see, we can arbitrarily write to this file. If we can arbitrarily write to this file, then we can get command execution as root. So let's try out this theory. Let's test and see if we are right. And the easiest way to do that is just dropping a reverse shell at the end of this file. So we can append, I'll go back to revshells here, and let's look for just a normal bash script. We'll go to reverse, and this one's fine. We'll copy this, and we're gonna go echo. Make sure you enclose this in single quotes. Bash-i, just basic bash script, it's gonna be RIP. And instead of 4444, I'm already using 4444 on this shell, so I can't use it again. I can't use that same port. I'll do 9001. And the double arrow here is append to id.sh. If I did one arrow here, it would just be overwrite, but we don't really want to do that because we want the shebang here to remain the same. So we're going to append this command to id.sh. So we'll append it, and it's kind of weird with this shell because there's no feedback, but if we cat out id.sh, we see the updated script here. So we see id test.txt and bash-i. Obviously, this is our reverse shell command. So in theory, if we listen on port 9001 and wait a little bit, we should see a root shell. If this, that is, of course, if this script is being ran constantly. And as I say that, we are now root at Ubuntu. We run it. Who am I? We are root ID. We are the root user. We can cd into root, LSLA, and grab the root.txt flag. And that is the box. As I said, it's pretty simple, but there's enough complexity in here where I thought it was worth making a video on, especially for you guys out there who are newer to cybersecurity, newer to ethical hacking. This is some serious vulnerabilities that are incredibly important, right? Having write access to a script that gets ran by the root user. But let's look a little deeper. Let's look at etc cron tab. And this is why, this line exactly here is why this is happening. So the root user there's a cron job here, which is essentially just an automatic process that happens at a specific time on a machine. So like after, this one's probably like after 5 or 10 seconds, it's going to run this command. In this case, we're cding into the home directory and we're running bash on this script. And of course, the vulnerability here is letting a low-level user, such as Tomcat or whatever our user was when we first got that shell, letting Tomcat edit this file. Because being able to edit this file and manipulate this file, it means that we have arbitrary command execution as the root user because the root user is running this file every so often. And that is the danger of a custom cron tab here. And that's the danger of having writable files that are ran by a super user. And the same concept would apply if we were the Jack user. And I'm not even sure if this is the proper method. Like I'm not sure if you're supposed to laterally move to Jack before doing this, but we have write access as the Tomcat user, so might as well take advantage of it. But the big idea here is taking away this write access if accounts don't need it. So the Tomcat user did not need write access to this bash script. And to be honest, you probably shouldn't even have access to read any of Jack's home directory at all. So just a few things to look out for if you're doing some system hardening on your machine. But that is it for the box. That is it for Thompson. Again, very short, very sweet, but I hope you learned something, anything at all. And of course, all feedback is appreciated down in the comments below. Let me know what you thought of this box. Let me know if you learned something new. And of course, I'll catch you in the next one. Happy hacking.